morning, everyone. It's a great pleasure to be here today to speak about our Delfi-PQ pocketqube. Actually, it is a pity that we couldn't see each other in person like last year. I really enjoyed the last year workshop because I think it's very important to stay connected as a community. But okay, we'll do it online and it will be fine. For those that don't know us, I don't think there are many out there, but we are from TU Delft, Dutch University, one of the 4 technical universities, which is composed by 8 faculties. And just to give you an idea about how big we are not extremely huge university compared to some universities in UK, but we have around 24,000 students last year. We are from aerospace engineering faculty, so one of the 8 faculties of TU Delft, and we are very international oriented faculty because we have a full English taught program and we have about 47% of our international students in these flat weeks. But my group is from a section of the Department of Aerospace Engineering, and this is a space system engineering. We are not a very large group. We are 12 scientific and staff members, and we have 12 PhDs at the moment working on different projects. Our key projects were the Delfi nanosatellites, Delfi-C3 and Delfi-n3Xt, and now we're busy with the Delfi-PQ. We cover a broad range of expertise, in general nano and microsatellite engineering, distributed space systems, navigation, propulsion, in general system engineering, miniaturized instrumentation, and radiation effects assurance. The expertise on space engineering and space-related research is not only happening at the aerospace engineering faculty, but there are groups across the university in different faculties. And for this reason, it was created the Delft Space Institute back in 2015, which is bringing together people from TU Delft, but in different faculties. We have 3 main focal themes: sensing from space, distributed space systems, and space robotics. And the Delft Space Institute was really supportive during the development of Delfi-PQ, so we are very grateful for the support. In-house, we have some facilities to build satellites, clean room that was used for our CubeSats before, and we are very happy that finally we got to use it again for Delfi-PQ. So you can see Stefan and Chefcat, the last testing of the satellite that happened last week. And of course, Chefcat is the contact point if you're interested in knowing more about our clean room and the activities can be performed there. We also have a TU Delft ground station, which is situated on top of a very high building of electrical engineering. This is 90 meters high, and it is equipped with multiple antennas, which we and VHF and spend for downlink. And this is run in collaboration with ISIS, the company close by that is developing CubeSats. Contact point is Stefano Speretta. So the Delfi space program in general has as an objective hands-on education. We are a university, so we are really interested in training our students with hands-on projects. But we are also focusing on miniaturized technologies. So we believe that the future in space miniaturization. And we provide end-to-end engineering for very small satellites. So as I mentioned, we have a past in CubeSats. We have developed 2 CubeSats, Delfi-C3 launched in 2008, and Delfi-n3Xt launched in 2013. Delfi-C3 is still operational, so it's still giving signs of life, while unfortunately Delfi-n3Xt had a failure only after 3 months after launch. And now we are developing Delfi-PQ. We are very proud that we are going to deliver it to Alba tomorrow. So Delfi-PQ team is composed by Stefano Speretta. He is our communication engineer, but it was promoted to system engineer because in the last weeks he did everything to make the satellite ready for launch. Then we have a Shefkat, our electronic engineer. He also did everything from mechanical engineering to soldering. Again, very, very important member of our team. And then Casper, it was a previous student of us, and he provided the software development for Delfi-PQ. And myself and Ebra were just the project managers. We had some very interesting collaboration with the Dutch industry, which is of course very appreciated by the university because we are a public university. And we had a great support from Airbus. They helped us with the solar panels of Delfi-PQ. Stellar Space Industry provided the structure of the satellite. GTM was also very helpful in helping us with the vibration test, providing the adapter. As a space, we collaborate on administrative things like the insurance of the satellite that are also important, and the ground station, of course, and Thales, where we performed the vibration test last week. So the Delfi-PQ is a 3P pocket cube. You probably know about it, but yeah, this is the end design that we finalized finally. And Stefano will give a talk dedicated on all the details about the design of Delfi-PQ. So here I just want to give you a very, very quick overview of what's inside our satellite. We have a EPS, which is composed by body-mounted solar panels, so we don't have deployable solar panels like FOSSA. We decided to go for body-mounted solar panels. We have the communication system. The onboard computer is based on a SP432 microcontroller. We have an ADC system composed by 3 magneto-torquers and 1 MIU. And also we placed the 4 laser retroreflectors on the satellite in order to be tracked from ground in an easier way. And we are ready for launch in December 2020 with the cluster 3 of Alba Orbital. Thanks a lot, Alba, for giving us this opportunity. We were really hoping to fly soon our satellite. Now, we performed, in my opinion, a very important analysis on the orbital lifetime of our satellite. That was done by Jasper Baumeister, the previous project manager of Delfi-PQ. There's a paper published on this, so if you're interested, please have a look at it. It's very interesting, and it's also a very hot topic, mitigation of debris in our community. So the study was performed with different assumptions. We looked at Jasper mainly looked at different mass over area ratios and different scenarios. And now we performed a simulation with Drama based on the information that we got about the orbit we will be deployed to from Momentus. So last week we managed to go to a vibration test facility in Holland, quite far away from Delft. It was a long drive, but we were very happy because due to the COVID-19 situation, facilities are closed, and it was really difficult to get access to this facility. But we managed, and you can see Delfi-PQ mounted on the vibration table, and everything went fine. So we are very happy that this was done. So now conclusions. Despite all the difficulties that we had during the COVID-19 pandemic, we had to work from home a lot. You can see Stefan and Shefkat enjoying the last testing of the satellite at home. and we had the delays in procuring components. It was really a nightmare. We had really many problems, but we managed, and we are ready for integrating Delfi-PQ with the Alba Orbital Pod tomorrow. Chef Cat is there in Glasgow, so he will be participating to the integration. And we are really excited to be launched in December 2020. In the future, what we want to do is to demonstrate pocketquube's inter-satellite communication in order to implement distributed sensing systems. And this could be GPS, GNSS sensors, and radiation sensors. There is a small group in our group that is researching on micropropulsion. So we hope that in the near future we will be able to demonstrate also micropropulsion for pocketquubes. And we are really looking forward for a closer collaboration with the other pocketquube teams. I think it was great to stay in touch, but I would like to see this more for the future launches, so that we can share, for example, environmental tests and other experiences. So that was it. Thank you very much for your attention. And you can email, you can have a look at our webpage, or follow us on Twitter. I'm happy if there is any question.